Welcome to part 2 of our van build series. Last week we focused on framing out our van, and this week we're going to be focused on pre-wiring and getting our electrical system set up. Alright, since we're pre-wiring today, we went ahead and went to Lowe's. Starting off, we got some 14 gauge wire. This is what we're going to be using to wire our van. So we got a red and a black, and then some zip ties. Everything that we are going to be powering is going to be outlets, a water pump, our fridge, our puck lights, and our 2 max air fans. We have a general idea of where our battery and our light switch and our outlets are going to be, so we're going to be stringing the wires around so that they will be in place for when we are ready to run power to those. Later on in this video, I am going to do a deep dive into your electrical setup for your van. It's going to be more specific to how we're doing it, obviously, but I'm going to try to give you a little crash course on how electricity works. In the next few clips, you're going to see how we pre-wired. Just strung the black one through all of the holes, and now we're gonna do the red one.
Dance the night away, hang out the whole next day, laughing, having fun.
Have our battery over here. We put all of our wires here, let them run up through these holes. So we've got our wiring for our fan. These be for our puck lights that are gonna go across, and then we've also wired for our back fan. We also went in with some tape and just labeled those. We just finished pre-wiring the majority of the stuff that we needed. However, we did run out of wire, so we do need to go back to Lowe's. All of that's left is gonna be our outlets. We just got back from Lowe's, so we're gonna finish wiring everything. We set up our wires. We're gonna have 2 12-volt outlets on this side of our bed and on this side. So one there, one there. We'll have one more small wire running to sit kind of in this area. That is gonna be one more 12-volt outlet. So once we finish that, that is gonna be all the wiring that we need to do. We now have all of our wires running where they need to run. This is done for when we need to run power through these. All right. So as you could see, we did finish our pre-wiring today. This part of the video, I'm going to get more into how our electricity is going to be set up and just a general overview of how to wire your van, because I think that the electrical part of building your van can be one of the most daunting things. Personally, it can be really confusing for me, and so if this video can help anybody out there, I'm going to try to break it down in a way that I understand it, and maybe this will help. And I have taken some notes here to try to keep this as simple as possible. I may include me kind of drawing some of these things out to also help picture it, but there are 2 ways you can wire your van. There is AC or DC. AC is alternating current, DC is direct current. For our build, we are going to be doing both. The simplest way to explain what they are is by saying the name. AC, which is alternating current, means when the energy is flowing or when the electrons are moving, it is alternating. So it kind of moves up and down. I want to think of DC as a straight line because it's a constant flow of energy. The next question would be, why would you want to do AC or DC for a van build. For us, and for most people who are doing a van build, they are getting their energy from solar. So you have to wire with a DC circuit because solar panels will only produce a direct current. So in your van, really the only reason that you would have AC power is if you are trying to power household appliances. Like if you're trying to have a toaster oven, you want to have an air fryer, you know, things like that. And the reason that AC is used in houses is because there is less energy loss over a longer span. With DC, if the energy has to travel a long way, there will be lots of energy wasted. With AC, still lose energy from moving far distances, but it's less than what you would lose with DC. Now I'm going to get into what are volts, what are watts, and what are amps. A volt is going to be a force that will make the energy move. So for example, if water is moving through a hose, a volt would essentially be the pressure that is going to move the water. Amps are a way to measure electrical current. So if we go back to our example of water, it would be the volume of water flowing. So how much water is in the tube or in the hose that's flowing at that time. A watt is the amount of energy that an electrical device is burning per second. Let's say we have our water running through our hose. The water is now at the end of the hose and it's sitting above a wheel. So as the water runs out, it's going to spin that wheel. Watt is the force of the water running out. How many water droplets are falling to make that wheel spin? If you have less water droplets, it's going to spin slower. If you have more, it's going to spin faster. With watts, the more watts that you have, if we think about a light bulb, the more watts that are running to a light bulb, the brighter it's going to burn. When it comes to talking about watts, voltage, amps, try to not worry so much about that because that is not something that you have to overcomplicate. While it can be confusing to understand it, I think the best way to see it is think about the flow of energy as water. That has always made the most sense to me. Okay, so now that I've confused you with all of that, I am now going to be talking about what amp hours are. When it comes to the breakdown of understanding voltage, watts, and amps, amp hours are gonna be something that will stand out because if you're planning on wiring things, you're gonna have a battery. You do need to know what amp hours are, but I'm still gonna try to keep it very simple. An amp hour is how many amps are going to be produced in 1 hour. So if you have a battery that has a capacity of 100 amp hours, that means in 1 hour it will use 100 amps. How does that work when it comes to powering things? Let's say that you have something that requires a 10 amp power supply and you're going to be wiring it to a battery that has a 100 amp hour capacity. If you wire that to that battery, that means it takes 10 amps per hour. An electrical device that requires 10 amps would be able to run for 10 hours on a 100 amp hour battery. Going along with talking about your amp hours, I'm going to go back to using water in a hose as our example. In this example, you want to think of your battery as the tube that the water is going to be running through. The amps are how much water is in that tube. So how much water can the tube hold, which would essentially be how many amps are going to be able to be stored in your battery. Really, anytime you're hearing this, I always try to compare it to water. In your electrical setup, you're going to have a battery. You will most likely have a 12-volt battery, which would lead you to ask, why would I use a 12-volt battery? They can hold energy for a long time. Most readily available appliances are already built to operate on a 12-volt power supply. It would make installation of those appliances much easier. I'm also going to get into why you need to have a positive and a negative wire. I feel like this is something that I never see explained. Once you know, it is a simple concept, but you have to learn it. We did go with a black and a red wire for ours. You can do any color. The example that I'm using is how you would power a puck light. You're going to have your puck light, you're going to have your positive wire and your negative wire running down to your fuse panel, which is going to be your energy source. The fuse panel is attached to the battery, so you can think of the fuse panel and the battery as one source for this example. Energy is going to run from your positive wire up to the light, and then the energy is going to keep going down from the negative wire to that fuse panel. So essentially you are creating a circuit, which is why you need to have both. If you only had one wire, the energy is still going to run through that wire, but it has nowhere else to go to create that full circuit, so you have to have both. Another thing that I want to address is, why does wire gauge matter? Wire gauge will determine how much a wire can carry. If the wire has too much energy running through it, it can cause wires to overheat, and then you can have very hot wires, which is not something that you want to have. 14 gauge is usually the go-to. You need to think about what exactly do you want to power and how long is it going to be running for. If you are going to have a solar setup, the main things that you're going to need are going to be solar panels, a battery, a charge controller, and a fuse panel. Obviously wiring as well. Charge controller is going to be for preventing your battery from becoming overcharged from the solar panels. Fuse panel is how electricity is going to be controlled and distributed to your outlets and your lights and whatever else you're wiring. You should not wire things directly to your battery. If you wired everything to your battery, it can cause overflow of electrical current, which can cause short circuiting and overheated wires, which is something we do not want. We are going to have AC and DC power in our van. I am mainly going to focus on the DC aspect. We'll still show you how you can get AC in your van. I'm going to have it somewhere on the screen. You're going to be getting power from your solar panel. Your solar panel is going to be connected to your charge controller. The charge controller is then going to be connected to your battery. Once you have that flow of energy, you will wire directly into an inverter. Inverter is what will change direct current to alternating current, so you can get your regular outlets that you would find in a house. Some inverters do come with the outlets already on them. We are going to have all of our electrical stuff tucked away, so we're going to have outlets wired off of our inverter. I'm now going to walk you through our electrical setup. We're going to have our solar panels. Our solar panels are going to be wired into our charge controller. The charge controller is going to go directly to the battery. You're going to have a 12 volt or a DC side and an AC side. I'm separating it this way so you can kind of see how that's going to be broken up. We're going to start with the 12 volt side or the DC side first. The battery is going to run to the fuse panel. Off of our fuse panel, that is where we are going to power our lights, our water pump, our fridge, and our 12 volt outlets. So that is going to be the DC side. The AC side is also going to be wired from our battery. Instead of running to the fuse panel though, those wires are going to run to our inverter. Our inverter will then have wires that are going to be running to our AC outlets that are going to be able to power our appliances. That is going to be a very, very simple breakdown of our electrical setup. I think I'm going to end the video here. There's your crash course on your van electrical system. I hope that this helped. I hope that it made sense. Hopefully you can take something away from this video when it comes to your build. Definitely take it one step at a time. Take it very slow. The more you just take time to understand what it is that you're doing, it's going to make things a lot easier. Thank you for watching, and we will see you next week. Bye.